Okay, guys, let's talk about water today. So let's start out with super easy stuff that we know. Say water's chemical formula is H2O. That means it's made up of two hydrogens and one oxygen. Now, if we draw water, we've seen this before. It kind of looks like Mickey Mouse. So we have a hydrogen, and we have a hydrogen, and then we have an oxygen right here. But what we need to concentrate on are the charges. Okay, hydrogens are positive, or at least kind of positive, and then oxygen right here is negative. Now, if we draw the periodic table of elements, just pretend that that's it. If you look for oxygen, oxygen is way over here in the top right-hand corner. And one thing we need to start remembering is the further right you go and the further up you go, this means you become more electronegative. And what electronegative means is it is super negative, and it likes to steal electrons, okay? And so this is something that we're going to kind of focus on every time we see oxygen involved, because as soon as we see oxygen, then we know that he's going to want to bind with a bunch of other different things, which actually allows water to have a bunch of its different properties. The first property that we can talk about is the fact that water is a polar molecule. And polar, that just means that it has a charge. And because this oxygen over here is really, really negative, my water overall has a negative charge, which really works out in our favor as far as water properties go. Because if I put a water molecule right here with some positives, and then my negative, if I put another water molecule right next to it, you guys have seen this before. If you put water on a table and it starts to bead together, that's because we know opposites attract. And so this negative of one water molecule is going to be attracted to the positive of the other, right? And this property right here, when I'm attracted, when one water molecule is attracted to another, this is called cohesion, okay? Because cohesion is when water binds to water. And the reason it's able to do that is because water is polar. It means it has a charge. And so if you were to drop a bunch of water droplets close to each other, they would start to bead up into one big molecule because they become attracted to each other. Now, the bond right there that we just drew of the water binding to each other, this is a really important bond. This is called the hydrogen bond. And that's because it's bonding to a hydrogen over here. Now, these hydrogen bonds are very, very weak. And that is going to account for a lot of the water or the water's different properties, is because those hydrogen bonds are really weak. That just means, since they are very, very weak, that they can break and form very quickly. And that's why, if you look at water, and I have it in a bottle. So here's a bottle. There you go. And there's my bottle. And if I put water in here, if I start to shake that bottle up, right, if I just kind of move it back and forth, that water seems to slosh from one side to the other. That's because these hydrogen bonds are breaking and forming. So here's water, here's water, here's water, here's water, here's water. And so these bonds break and form just as quick as they can whenever that water starts to move back and forth. And so that's going to account for a bunch of the water's different properties, is because these hydrogen bonds can break and form really, really quickly. Another water property, besides the fact that it's polar and it's hydrogen bond, or that it has these weak hydrogen bonds, is that water can also bind to other surfaces. This is called adhesion. And adhesion is when water is going to bind to another surface, whoops, but that other surface has to be polar. And we've actually seen this before, especially if you've taken chemistry. You know, we've all seen if you have like a test tube or if you have glass and then you put water in it, that it tends to creep up the sides, right? That was called a meniscus. But the reason a meniscus happens, so if I were to take that and then just pretend we zoom in really far, the side of this is glass, but glass has an overall charge. Glass has a negative charge. And so when I start to put water in here, so here's a water molecule, here's another water molecule, here's another water molecule, these hydrogens, because they're positive, tend to stick to the glass. And when that happens, that's going to allow them to kind of stick here, but because there's nothing in the middle, there's nothing for them to be attracted to, and that's why you start to form that meniscus shape, but that's because of adhesion. Another water property that deals with the hydrogen bondings in the polarity, this is called surface tension. Say surface tension. Surface tension. This is what allows water bugs to stick on top and stuff. So if I were to draw the surface, like right here, there's the surface. So here's the surface, or like the outside, and then this is going to be more water down here. And if we just pretend all of these circles, these are different water molecules. So we have water just everywhere. And we've talked about how water can break and form bonds really quickly. So break and form, break and form, break and form, break and form. And so now that one's broken, and that we put that one there. Now that one's broken, we put that one there. That one's broken, put that one there, etc., etc. But when you start to look up here at these water molecules, they don't have anything to interact with above them. And because they don't have anything to interact with above them, that means the bonds, the hydrogen bonds that form between these water molecules actually they become super close together. So the water molecules, here's a water, and then here's another water. These bonds that form between them actually become tighter. And because these become tighter, that's going to form a film on the top. And that film is going to allow different types of things to be able to float on top. Like let's say we have a little water bug, right? Say water bugs are able to stand on top because they're light in mass and they're able to stand on those bonds. But then as soon as I push down on that bug, he is going to fall through the water because he breaks the hydrogen bonds. So surface tension, okay, that's going to allow my water molecules to become a little bit closer together. Now, going back up to this one, when we talked about adhesion, we can also see another water property. This is called capillary action. Now, capillary action is kind of what we saw with the water creeping up through the tube, right? Because the water is attracted to the sides of the glass, they tend to creep up, and because there's nothing here in the middle, then it seems to stay down. But when capillary action is happening, this is when we see this. This is going to be water moving through a tube. And we see that, especially if you guys have a drink. So here's your cup, and then here's your water level. And then let's just put a straw in here. And so when you put a straw in here, you actually usually see that water level come up higher than the rest of your drink. That's because the water is going to be attracted to the sides of the straw, and because of that, he starts to creep up. That's what capillary action is. We actually see capillary action a lot within our blood vessels. Say that helps move the blood. And we can also see this with water going through different plants, right? If we drew a picture of a tree, here's my tree, and you know that the leaves are all the way up here. Well, the veins that you see on the leaf, those are actually tiny, tiny little tubes. And so the water, it's all the way down here in the soil. It's going to move up through the root system. So here's a root. So the water is going to move up through the root, through those tiny tubes, all the way to the top. And that's because of a little bit of a vacuum created by some different processes that are happening, but also because of capillary action. And then when we talked about surface tension we've actually seen before as well. If you guys have done that cute little experiment, like if you have a penny right here, and then if you start dropping water on the penny, it forms that nice little bubble, right? Well, it forms that bubble because of cohesion between the water molecules, right? And that's because water is polar, and then that's going to create a surface tension, and that's why you start to see that nice little bubble. Another water property that can be explained a lot by the hydrogen bondings is the fact that water has a high specific heat. And what high specific heat means is that water is able to hold heat very well. Let's try to write that word again. Very well, because of the hydrogen bonds. Remember, we talked about how hydrogen bonds can break and form really fast. Well, because they're able to do that, that means they're able to hold the heat really, really well. Because when we talk about heat, we're talking about temperature, and temperature is the average kinetic energy of something. And we know kinetic from way back in physical science. Kinetic is talking about the energy about when something's moving. And so if you have these different water molecules, so here's a water molecule, here's a water molecule, here's a water molecule, because of that, these hydrogen bonds can break and form really, really fast. So they can break and form, break and form, break and form. Because they can do that, and because water can move relatively fast, all of that heat starts to get stored in these different hydrogen bonds. And so because those hydrogen bonds can break and form so quickly, they're able to hold the heat really well, which we've seen before. Like if we talk about, if you guys are in a pool, so like here's a nice little pool, and here you are. Look at how much fun you're having. There you go. Say there you're in the pool, and then all of a sudden, it was sun shining out, and then you stayed in it for a super long time, and now it's nighttime. When you get out of the pool, you become really, really cold. Okay? And you're cold because that sunshine, say when it shined into the water, that water was able to keep that heat in there because the hydrogen bonds break and form so quickly. But as soon as you get out of the pool, you get really cold because you're not surrounded by the water anymore. Water is known as a really good heat sink. I'm able to keep my heat inside really, really well, which is also explained by, if we draw a rough thing of the United States, there you go, that's the United States, and we talk about San Francisco average temperatures are around 70 degrees, which is really awesome during the summer and during the winter months because it's always mild. Well, the reason it's mild is because when the sunshine shines down into the ocean right here, it's able to hold that heat really well. And so when the temperatures get really cold, that water is going to let off a little bit of heat and moderate the temperature. And when it's really, really hot outside, it's able to hold the temperature really well. So high specific heat is another awesome water property. One of the other ones is kind of due to water's density. And so when we talk about water's density, you know that water can be in three different forms, right? It can be in liquid, it can be in gas, and then it can be in solid form. All right, well, we've already talked about water in the liquid. Water is liquid because the H bonds break and form quickly, and that's why water can slosh back and forth. Versus if I'm looking at a gas, say the H bonds break, but they don't get to form anymore because those water molecules, they start shaking so rapidly that they just start to fly off into the atmosphere, and that means they can't form a hydrogen bond anymore. Versus when I look at solid water, that means the H bonds form, but they don't break. And the reason that is because when I have my water molecule, so here's water, here's water, here's water, and then when those hydrogen bonds form, they actually became really, really rigid, right? Because my water molecules don't have kinetic energy. They have very little kinetic energy anymore. And since these are barely moving, these hydrogen bonds become pretty rigid. And when they become rigid, they also can form an air pocket in there. And those air pockets are going to make that structure a lot less dense. And if that's a lot less dense, we know that solid water is ice. That's why ice floats, which seems kind of silly, but it's actually a really important idea, because if I have a pond right here and it becomes, well, let's go ahead and draw a fish. Look, there's a fish, and then there's a plant. And so if I were to have ice form on top and ice didn't float, it would sink and it would kill all of these things. But ice does float. And since ice can float, it will stay up here. And then that means, because remember, water is a really good heat sink, this is going to moderate the temp of the water down here, because that heat is going to stay trapped down here. And that's why even when it gets really, really cold in a bunch of different places, all the aquatic life just doesn't die, because that ice up here forms, and then he's able to help hold the heat in because he forms that nice little layer on top. And so if we go back through all the properties of water, okay, so properties of water. First one, the fact that it's polar. The next one is cohesion, okay? And cohesion is due to the hydrogen bonds. If I look at adhesion, adhesion again is because of H bonds, and we can throw in polarity right there. Another water property was high specific heat. Oops. High specific heat. And the reason water can have high specific heat is because those hydrogen bonds can break back and forth really quickly, which is going to allow me to hold heat really well. We can talk about density. Density is again because of the hydrogen bonds. We can talk about capillary action. And capillary action, again, is going to be because of the H bonds. And my polarity. Let's see, did I forget anything? Oh, surface tension. And then we also have surface tension. In surface tension, again, because of the hydrogen bonds. And then my very, very last property of water that I forgot to mention is the fact that he is a universal solvent. All right, so let's go through the words. If I'm a solvent, that means I am doing the dissolving, and that's going to be my water. Versus my other part, my solute, That's what's being dissolved. And maybe my example here is going to be salt, NaCl. And so if I look at NaCl, and then I start throwing water around him. Okay, so there's some water, and there's some water. Well, if we think about overall charges, sodium is positive and chlorine is negative. And I know that my hydrogens are positive, my oxygen's negative, positive, positive, and negative. And so we know opposites attract. This oxygen is going to be attracted to the sodiums, right? And then, of course, the chlorines are going to be attracted to the hydrogens. Well, like anything ever in this world, if things start to become attracted to something else, that naturally is going to break up. And so when that breaks up, now you're going to have the sodium that is surrounded by these oxygens. And then vice versa. You're going to have the chlorine, which is going to be surrounded by the hydrogens. So because water's polar, that's going to break that molecule apart. That part right there is called dissociation. And that's why he's known as the universal solvent, because he can break things apart and he can dissolve things really, really easily. The only thing about being a universal solvent is that it can only dissolve other polar substances. So you can't dissolve things that are nonpolar, like let's say oil, but we can cover that in another video. So there you go. That's a quick rundown of all the stuff about water. Hope it helps.